Okay, I'm making this video here in second period about concurrency, area, and composites. Okay, so the worksheet that goes along with this should be somewhere close to this link here in Schoology. You probably didn't do this in class, especially if you're in Moreno's classroom, but it's okay, you can do it now. So 1 through 8 are all vocabulary words. Okay, I want you to spend a minute, pause the video for reals, and think about the answers to these 8 vocabulary word questions. Okay, if you don't know your vocabulary, then you simply need to memorize it at some point, doing whatever you do to memorize things. Okay, so pause the video, come back a second, and check out all the answers. Okay, there are all the answers. So hopefully you have gotten most of them right. These are the vocabulary words that you're going to find on the first 2 questions of your test. Okay, the first 2 questions are vocabulary words on your test on Friday. Okay, number 12, estimate the centroid of the triangle formed by these 3 points. Okay, so here is some algebraic understanding of what is a centroid. What do I have to graph in order to find the centroid? I have to graph the medians. I can't find the centroid unless I have the medians. Okay, so let's take a second and plot A, B, and C on your grid. Now that we have your triangle, we need to do the medians. So the median goes from the vertex to the midpoint of the opposite side. The median goes from the vertex to the midpoint of the opposite side. So I need to figure out where the middle of each of these sides is. So let's do that by counting. Side AB is 1, 2, 3, 4, 5, 6. That's 6 units long. The middle of 6 is at 3. So there it is, 3 from top to bottom. Okay, for these other ones though, I'm going to make triangles. So I go over 1, 2, 3, 4, 5, 6, 7, 8. 8 units left and 1, 2, 3, 4 units down. Right, to get from point A to point C. So if it's an 8 left and then 4 down, where is the middle? Well, that would be 4 left and 2 down. So my middle of that side is there. Okay, 4 left and 2 down for my triangle from point A. And do a similar thing for B. I go over 1, 2, 3, 4, 5, 6, 7, 8, and only up 2. So that means I go over 4 and up 1. And there are all of my middles. Now, if I want to do the medians, I need to connect the opposite vertex with that midpoint. So there's 1 median. Here are 2 medians. And here is my 3rd median. And if you draw them nicely, they all intersect at a single point, right? So the nicer, the more accurate you draw them, the better the point will be. So this point doesn't look like it's at a nice pretty point. So I'm going to estimate this at being 1/2, so 0.5. That is the x coordinate. And probably like negative 0.5 as the y coordinate. Let's look at number 13. So here we're trying to find the orthocenter. Okay, so we need to think about if I am going to graph the orthocenter, what lines do I need to graph? Altitude. And those would be the altitudes. So let's put our triangle on your grid, and then let's see how it is that we're going to graph the altitudes. So now that we have your triangle on here, let's think about how we would graph an altitude. Okay, so an altitude starts at the vertex and goes perpendicular to your opposite side. Okay, so if I'm going to do the altitude from C, I need to know what is the slope of the line across from side C, or rather vertex C, right? Because if I want the line to be perpendicular algebraically, then I need to know what the negative reciprocal is, because that's what slopes are if they're going to be perpendicular. So if it's on a grid, we're looking at slopes because it's algebra. So the slope of this line is down 6 over 6. Okay, so this line has a -1 slope. AB has a -1 slope. Down 1, right 1. So I need to do a +1 slope from point C in the direction of side AB. Okay, a positive slope from point C, +1, which is down 1, left 1, down 1, left 1, down 1, left 1. This is the altitude from vertex C to the opposite side. Okay, let's look at the altitude from point B. So what is the slope of the line here, AC? What is the slope of this line? Hopefully you know it's 0, right? That's a 0 slope, the horizontal line. So which is a slope that is perpendicular to 0? -0, that's so cute. It's actually undefined, right? An undefined slope. So what kind of a line is perpendicular to a horizontal line? A vertical line. So we're going to do a vertical line from point B in the direction of side AC, right? A vertical line. So a horizontal and a vertical are always perpendicular. And now for our last side, from vertex A, what is the slope of side BC? Okay, so that's up 3 over 1, right? Up 3 over 1 to get to your next beautiful point. So then what's my negative reciprocal slope? -1/3, right? I reciprocate 3 over 1 to be 1 over 3, and I make it negative. So from point A, I'm going to go down 1 and 3 units right. Down 1, 3 right, down 1, 3 right. And I do this until I run into my opposite side there at BC. So let's see, where did all these lines cross? At the point 2, 1. So that is the coordinate of the orthocenter. If I want to find the orthocenter, I need to graph the altitudes. And the altitudes are perpendicular to the opposite side, and they start at the vertex. Okay, very good. Okay, now we have some finding composite area problems. So area is, of course, 1/2 base times height. For most problems, unless they're special, most problems. So on number 14, I have the triangle on top, which has a base of 22. So 1/2 of 22 times. I need to calculate the height, right? This is the height for my obtuse triangle. And I'm going to do that using the Pythagorean theorem. Good. 7 squared plus h squared equals 15 squared. So I solve for h. Square root of 176. Okay, so the height is the square root of 176, which my calculator can handle, right? It knows how to do that. So the square root of 176 times 11, or times 22 divided by 2. So the top one has an area of 145.931. So look at our bottom triangle. That also has a base of 22. So 1/2 of 22 times. Now I also need to calculate this height. And I'm going to do that using the Pythagorean theorem. So h squared plus 22 squared equals 30 squared. Okay, so anytime I have a height that I am trying to calculate, I am using the Pythagorean theorem, because that's good for all right triangles. And the height is the square root of 416. Okay, so my calculator can handle this, right? 1/2 of 22 times the square root of 416, 224.357. So now to find the area of them both, I add these together. and I use my calculator and get something in the area of 370.288. And maybe your decimals are a little bit different, and that's okay. As long as you show me the work on your test, I will be able to understand the decimal discrepancy. On to number 15. Okay, number 15 is really hard. Okay, I'm not going to lie to you because, well, it just is. So we need to calculate two things. We need to find the area of, or the base length here for your large triangle and the height for your large triangle, and then subtract the stuff from your smaller triangle, right? Or, wait a second, let's do this. Maybe this will be easier. What if I turn my triangle on its side right here, like this? Then now what side is my base? Now this side is the base, and all I have to do is calculate the height. Okay, so what if I flip my triangle around like this? I have to do less work, potentially, right? Less work. And that's what I'm all about, more efficiency. So what is the base length? 20. And what is the height? Well, that's going to be difficult. The height is, in fact, an altitude. The height is an altitude, so we're going to use a proportion. Wonderful job. We're going to use a proportion to calculate the height. So 4 over h is equal to h over 16. That is your altitude proportion from your similar triangles unit. Okay, and when you do this cross multiplication, we get h squared equals 64. So the height is going to be 8. So the whole entire outside triangle, the gray triangle, has an area of 80. So now that we have the gray triangle, we have to find the area of the white triangle. Okay, so I'm going to do a similar exercise. I'm going to call this the base, which is 10, and calculate the height again using that proportion. Okay, so this is a proportion problem. It will do 8 over h equals h over 2. And hopefully you can figure out that the height is going to be 4. So the white triangle on the inside here has an area of 20 square meters, right? Because half of 10 is 5. 5 times 4 is 20. So if I have a white triangle area of 20 and a gray triangle area of 80, then the entire shaded area for my answer is going to be 60 square meters. Okay, so these triangles both use proportions. They both use the altitude proportion in order for you to calculate the heights of your altitude to find the area for your triangles. Okay, here is the second page of this worksheet. These are all word problems, so you're going to have to draw your own pictures or imagine it in your brain. The base of a triangle is 3 times the height. Okay, base equals 3 times height, so B equals 3h. The area is 150, so what is the base length? So this is an algebra problem where we're going to replace B in your formula, 1/2 base times height, right? So we're going to do some algebra and solve this equation for h. So area equals 1/2 of the base, and the base was 3h. Okay, so when we have B equals, we replace B in your formula, in your area formula. Okay, so let's do this step at a time. What is 3h times 1h? 3h squared. And we still have this 1/2 business in front. Okay, so how do you want to deal with this 1/2 business?
Multiply it by 2 on both sides.
Multiply by 2 to get rid of the 1/2. Okay, that is the best mathematical way if, of course, you have an odd number in front of your h. If it's an even number, then of course half of that is pretty easy. So 300 equals 3h squared. So let's solve for h. Divide by 3, right? We do division first before we square roots. So I guess it just told you what to do, and that is square root. Okay, so the height is 10. The height is 10.
The base is 30.
So then the base, which is 3 times the height, the base of your triangle is going to be 30 centimeters long. The base is 30 centimeters. Okay, so in this case, we solved by taking the square root. We solved by square rooting. But here on number 17, it says the height is 10 more than the base, which is b plus 10. Remember, the variable comes first in all of these algebra problems. B plus 10 or b minus 10 if it was less than. And the area is 28. So let's go into your formula. 28 equals 1/2 of, base stays b, but what does your h become? B plus 10. We replace h in your formula with b plus 10. Okay, so the b's we distribute, right? This is b times b and b times 10, which is b squared plus 10b. And what do we do with the 1/2? Times it by 2. We multiply it by 2 to get it to the other side of your equation. And now, hopefully you recognize this, and we solve by making a quadratic. So we're going to get everything on one side of your equal sign. So b0 equals b squared plus 10b minus 56. Minus 56. So we're looking for numbers that multiply to give us 56 and add to give 10. Right, negative 56. So 10 units apart. What numbers are 10 units apart that multiply to give you 56? Okay, 2 and 12? No. 3 and 13? No. 4 and 14? Yes. 4 times 14 is 56, but we want the 4 to be negative, so that 14 minus 4 is 10. So we're solving this by factoring. So we can change our quadratic into a factored form, b minus 4 and b plus 14. So base equals positive 4 or base equals negative 14. So in geometry, we throw out the negative and we keep the positive. So your base is 4 feet long. Okay, which would mean that your height is 14, but that's not what we were asked for. Okay, so if you have a plus in your problem, you get a quadratic. And if you have a times, you get a square root. Okay, number 18, find the area of an equilateral triangle with a side length of 6. So there is a formula that I asked you to memorize for the area of an equilateral triangle, and that's it. X squared times the square root of 3 over 4, where x represents your side length. Okay, that is a specific formula to an equilateral triangle only, and it makes this calculation so simple. Okay, 6 squared times the square root of 3 divided by 4. We plug that right into your calculator. And that's what your answer is, 15.589 if we're going to round to 3 decimals. And area is always a squared unit, so we have square feet as your answer. Okay, this formula is very powerful. It can help us on number 19. An equilateral triangle has an area. So now we know that the area is 140.296. So we set it equal to the formula for an equilateral triangle. Take the area of the equilateral triangle, set it equal to the formula for the equilateral triangle, and now we algebra. The first step is multiplying both sides by 4. So 4 times 140.296. 561.184 equals x squared times root 3. The next algebra step is to divide by root 3. Divide by root 3. Remember, your calculator can handle this. Divide by root 3. And my calculator says 324. Exactly, 324 equals x squared. And then we square root at last. I don't know if this is a pretty square root or not. It is. It's exactly 18 centimeters is the length of the side of your equilateral triangle. So if it's an equilateral triangle, use the specific formula for an equilateral triangle. Okay, and then number 20 is about two triangles, so we have to calculate two different heights. Okay, so let's take a minute and do that. Triangle A has the same area as equilateral triangle B, whose side length is 15. Okay, so we can calculate the area for triangle B, right? This is triangle B, which is 15 squared times the square root of 3 over 4. If triangle A has a base of 20, okay, so that's the area for triangle B. Do you want to know what that is as a decimal? No, I don't. But I know that that has to equal 1/2 of base times height. Okay, so triangle B is equilateral. It uses a special formula. Triangle A is not, so it uses the normal formula. So let's see if we can algebra this out. What is half of 20? 10. Let's do this one step at a time. 15 squared root 3 over 4 equals 10h. So how do I solve for h? Divide by 10. So in other words, multiply by 1/10. So let's put this all in your calculator. 15 squared root 3 over 40, because 10 times 4 is 40. Okay, slap that all in your calculator. Let's see what you get. 15 squared is 225 times root 3 divided by 40. And I get a height of 9.743 inches. Okay, so a little bit of algebra with an equilateral triangle. Okay, now by no means is this all the problems, but these are some of the ones that I've seen some struggle on, so it's good to go over them again.